Hi, so last time is we talk about the different persons involved on the creation of the different theories about an atom, such as the plum pudding model proposed by G.J. Thomson, the planetary or the nuclear model proposed by Ernest Rutherford, until we came up to the modern atomic model that we have today, which is the electron cloud model. So today, an atom is defined as the tiniest particle of an element that retains the chemical properties of that element. All atoms are made up of the nucleus and the electrons. At the center of an atom is the nucleus, which is composed of protons and neutrons. These two units are collectively known as the nucleons. The nucleus is orbited by the atom's electron. Establishing the structure of an atom took a long time and concerted efforts of many scientists. After the postulation of Dalton's atomic theory, experiments and scientific inferences allowed scientists to conceptualize the structure of the atom and the properties of its particle. Until we came up to the model that we have here, which is the electron cloud model, which shows the different subatomic particles. We have here the protons, the neutrons, the electrons, and collectively we have the nucleus. Just like what we mentioned in the past meetings, so when we talk about atoms, it is defined as the smallest unit of a chemical element containing all the properties of that element. And when we talk about atoms, it can be further divided into the what we call subatomic particles. First one is we have here the electrons. When we talk about electrons, these are tiny particles that move around the nucleus carrying a negative nuclear charge equal to negative 1.6022 times 10 raised to negative 19 coulombs. Therefore, when we talk about electrons, these are negatively charged particles. Next one is we have what we call nucleus, the central part of the atom that carries its atomic mass. In the nucleus, we have what we call protons, the positively charged particles. So these tiny particles are 1,836 times heavier than electrons and carry nuclear positive charge equal to the charge of the value of the electrons. And lastly is we have what we call neutrons. Neutrons are tiny particles that are slightly heavier than protons and carry zero nuclear charge, or in other terms, they are neutral or they have no charges. I have here a table that shows what we call element, the atomic number, proton, neutron, electron, and the atomic mass. Now, going back to what I've mentioned a while ago, isn't it when we talk about the nucleus, it contains the what we call mass of an atom, on which it includes the proton and the neutron. Therefore, if you want to get the value of the atomic mass, you need to add the proton and the neutron. Okay? Next one, what if you want to find the value of the neutron? Just subtract atomic mass and proton. Next one, so we have your atomic number, proton, and electron. I also mentioned you a while ago that the number of protons is equal to the number of electrons. Therefore, the number of protons also indicates the atomic number. Therefore, the proton, electron, and the atomic number are all the same. I have here hydrogen. The atomic number of hydrogen is 1. Therefore, the number of proton is 1. And also, we have here neutron, which is 0, and the number of electron, which is 1, and atomic mass, which is 1. Now, let us try to fill up this table with the following values. Okay? For the second one is we have here an unknown element having a number of proton of 34, a neutron of 45, and an atomic mass of 79. So try to compute or try to find that missing element. Okay, very good. So that element is the what we call selenium. Okay, we write Se. Next, what's the atomic number of selenium? Very good. So it is just the same with the proton, which is 34. Next one is, we also have here the electrons, which is also 34. Very good. Next one is, let us try to identify the number of protons and atomic mass of osmium. Okay, so we have your osmium having an atomic number of 76. Okay, we have here the number of protons, which is also, okay, very good, it is also 76. Next one is, we have here the number of neutrons and also the number of electrons. Now let us add the value of the proton and the value of the neutron. Okay, very good. So therefore, the atomic mass is 190. Okay, so that is how you get the different values on this table. Again, so the atomic number, the proton, and the electron are all the same. Next one, if you want to find the atomic mass, is you need to add the proton and the neutron. And if you want to find the value of the neutron, just subtract atomic mass by the number of proton. Next one is, we have the atomic number and the atomic mass. I already mentioned you a while ago the atomic number and the atomic mass. Okay, so let's go a little deeper to this atomic number and atomic mass. Okay, when we talk about the atomic number, it is the number of protons in a chemical element, serving as its identity as written in the periodic table. So if we're going to take a look at your periodic table, so they are arranged in accordance to their atomic number, on which that atomic number also corresponds to the number of protons. The number of protons and electrons in an atom dictates its charge. Ideally, an element is neutral if both protons and electrons have the same number. If neutrons are added with protons, which are usually neutrally charged, they form the atom's atomic mass. The atomic mass, sometimes referred to as the mass number, is the number of protons and neutrons combined. I have here an illustration. So at some points you can see this on the periodic table. X here represents the element symbol. Next one is, on the upper part is, we have the atomic mass, which is represented by the symbol A, and the atomic number, which is represented by the symbol Z. Dmitry Mendeleev, a Russian chemist, created the very first periodic table, arranging the elements according to their atomic masses. So after Dmitry Mendeleev created the first periodic table, is we have here Henry Moseley. So Henry Moseley decided and also concluded that there are some gaps on the periodic table. So there were some gaps in it, hinting that there were and still elements yet undiscovered. So Henry Moseley argued that the elements must be arranged through their atomic numbers. This configuration, proposed by Henry Moseley, is still being used in the modern day periodic tables.